Heine-Borel Theorem. Every closed and bounded subset of the real line is compact. Closed means it contains its boundary points. Bounded means it fits inside some finite interval. Compact means every open cover has a finite subcover. 3 key terms. Closed, a set containing all its limit points, including its endpoints, shown by filled dots at the boundary. Bounded, a set that fits inside some interval from -m to m, compact, no matter how you cover it with open sets, finitely many always suffice. Take any closed bounded interval, a to b. Now cover it with open sets, as many as you like, possibly infinitely many. Our goal, show that finitely many of these open sets already cover a to b completely. Proof by contradiction. Assume the cover has no finite subcover, that you genuinely need infinitely many sets to cover a to b. We will show this assumption leads to an impossible conclusion. Cut the interval a to b exactly in half. At least one half has no finite subcover, otherwise both halves have finite subcovers, and combining gives a finite subcover of the whole, contradicting our assumption. Call that half a1 to b1. Cut again. One subhalf has no finite subcover. Call it a2 to b2. Keep cutting forever. We get a sequence of nested closed intervals, each inside the previous, whose lengths shrink to 0. By the nested interval property of the real numbers, there is exactly one point x star belonging to all of them. That point x star is trapped inside every interval. Since x star lies in a to b, some open set G alpha in our cover contains x star. Because G alpha is open, it contains a whole neighborhood around x star. Our intervals keep shrinking. Eventually, one interval an to bn is so small that it fits entirely inside that neighborhood. So an to bn is covered by just one set G alpha. But we said every an to bn has no finite subcover. One set is a finite cover. Contradiction. The contradiction kills our assumption. Every open cover of a to b has a finite subcover. The closed bounded interval a to b is compact. Since every closed bounded subset of the real line sits inside some closed interval, every closed bounded subset is compact. Heine-Borel theorem proved.